Recording. Screen is. Ooh. Let me get my manuals very quickly, quick, so that I can start. Articles, memo, right, and right. All right. So, as you know, we're gonna jump to exercise number 4. We're moving fast. Be ready. Exercise number 4. I'm just gonna share my screen now so that everybody can see. Right. So, okay, number 1. Okay. So here we are filling plastic pallets. Huh? And one of the most important concepts to understand is indirect actuation. Mind you, I did emphasize that. Oh, so someone will go to. I did mention that I never ask direct actuation related questions. I only deal with indirect actuation. So the moment you see the term indirect actuation, you must know that it is what we are doing. Anyway, why password? Input password. Let me change this. Right. So indirect actuation is one of the and I don't even mention it. I don't even mention it. That indirect actuation. Okay. So you should be able to select correct solenoid valves based on specific requirements. That one is very important. And in industry, because I did tell you that I'm not dealing with industrial engineers, I'm dealing with a different caliber, which is mechanical students. You are going to be required to amend some of the valves when you're in industry. So that is something that as you learn how to spec, you'll definitely learn how to amend. So the best way, as I said even last week, is when it comes to difference between 3-2-way valve and 5-2-way valve, which one should you buy? I always suggest 5-2-way because it's amendable. You cannot take 3-2-way valve to 5-2-way, but you can always take 5-2-way valve to 3-2-way. So you can convert it. So they are covering that aspect of valve conversion here. Although I am not training such stuff. Remember, pneumatics basically are something that you are required even to design the amount of force that the cylinder needs to have, the compressor and everything, all those calculations that you do either in hydraulics or either in fluid mechanics, they still apply here. But in terms of selecting the diameter of the cylinder, the rod, the length of the cylinder, all those factors, you will be required to understand them in future. I don't do theoretical aspects of pneumatics. I just teach designing basic circuits. but you are a mechanical. You know that you can't just take a cylinder rated at maybe 100 bars and put it in a plastic production system. It will crush everything that passes there. You understand? So yeah, something like that. You definitely. I don't think the calculations are difficult. If you want me to share them with you, I will definitely. After every, I think some of the topics, in particularly basic pneumatics, I can even give you that booklet for basic pneumatics so that you can use it in future. Because you guys, one way or the other, you are mostly likely to work with pneumatics, hydraulics, and electronical stuff. So it's just given. Recently, as I told you before, I'm getting a large number of students whom are required to have knowledge of PLCs, and they didn't do PLCs with me because in the past we used to have two different departments: industrial doing their own thing, mechanical doing their own thing. Now we are, uh, having an industrial element in mechanical, whereby I take you through some of the labs that we're doing this side. So I don't do experiments, as you can see. I do course-based labs. Okay, plastic pellets need to be filled from a storage silo. The silo or silo, depends whichever way you want to call it, is open and closed with a flap. And then the process will. Can I take this one to my colleague? Ah, she hang up. What's wrong? Something could be wrong that side of QK. Can I just call one of them? Then I love technology too much, so I thought I could use the other thing. So let me Google what's a flap. Valve, flap valve, flap valve. Images. Oh, number one. Found it. Where is it? So on the ordinary flap that I'm used to is this one. Yeah? It's normally used for generators because the exhaust is facing upward and you need that flap to close for water, especially when the generator is not in use. But once the generator has been in use, because of the smoke, the combustion is warm, so it obviously will melt the water, so water won't go in. So whenever you throttle it, then the flap opens and then the gas is released. So but the one that they're talking about is this one over here. So it still looks like a normal valve, but it's just that it's having. Remember, they are different. There's the one that is a ball valve inside. So the ball is screwed in two ways, and then as it rotates, it has a point where it has an opening. So a flap is just a solid still, still some, still what? Still plate, yeah. Then it either goes up because there are those ones that can go up, or it turns. So it depends with the type of mechanism that they're using inside the the valve. So that's the valve over here. They're using a flap. So as I said, you need to understand the types of valves that exist out there. You will be required, especially as a sales engineer and you work in a company whereby they're dealing with pumps, they're dealing uh, with all sorts of pneumatic related stuff. You will be able to. So the flap is opened by pressing either, yeah, now English comes in here, either one of two push buttons. Hey, uh, either one of two push buttons. Okay, so in total there are two push buttons, and any of them can actuate the flap valve. So when we go to gates, logic gates, we have an AND gate and we have an OR gate. So if I were to ask you, which one is it, an AND or an OR in this case? It's an OR. Yes. So any of the two push buttons can actuate the system. All right? Then, and the bulk materials is emptied out. Yeah? So we want to understand what happens when you release the push button. That scenario, I will always put it in place. When you press, then you expect to release the push button. In most cases, in automation systems, when you press and release the button, the process carries on. So I will take you gradually to that understanding of what really happens, what sustains or what retains the signal for something to keep on repeating the same process. So when the push button is released, the flap is closed. Okay, these ones are still straightforward. So you press, actuate, and when you release, it goes back to normal. Okay? Then they want us to use a single acting cylinder, and I did mention that I will never require you to use a single acting cylinder. But let's see. The control of the cylinder will be executed indirectly by means of a push button. Remember that two push buttons. In the event of electrical power failure, the cylinder piston rod should be advanced to the forward end position. All right. So these guys, they think that they know. Yeah? You need to understand these types of of valves that exist. So when you say something needs to be in its advanced position, it can simply mean that the cylinder needs to be normally extended by nature. So that's what I am picking up here. So so now when you buy solenoid valves, I think that's what they were trying to say. When you buy these solenoid valves, you buy them preferably normally open, then you can convert them to normally closed. So I have a feeling that they want us to have it as a normally closed. Actually, let me put it like this, because remember we said pump B is all when it's open there's water flow, but in a switch when it's open there's no electrical flow. I must not confuse myself. It's very easy, but you know what I said last time. If I contradict myself, just go back to the basics. So they are expecting us to convert here a standard. Okay, so describe valve types. Okay, like okay. So this example, I don't think we might have it, but let's try it either way. I don't think we might have. The software might not cater for this example. I'll confirm that in a second. Secondly, okay, guys, whenever an error arises, and it will always arise, even on your own personal computer, you don't raise up your hand and you panic, you read. So, according to this, it says that a certain diagram was open and I didn't close it correctly. So, do I want to restore that circuit? So basically, it continues from whatever circuit we have left on last time. So I would say, yes, I want to bring it on so that I can make a clear comparison. So this one looks like this, because remember it was a single acting, double acting. So let's see how this today's one will differ. So the single acting cylinder and a normally open valve and what do you call that? This a service unit to clean our air, and it also filters the humidity, né? The water, right? And maybe I need to entertain one statement they're talking about here. Let me entertain one statement because it's going to help you. I know you know the answer. You're dealing with compressors but I will there. It states that in the event of electrical failure, the cylinder piston rod should be advanced to the forward end position. What generates what helps? Okay. Oh, the whole. I want to say what causes the compressor to run? Electricity again. It runs on electricity again. And then, but what happens to the compressed air should electricity, not chilling as usual? What happens to the compressed air? Does it vanish or what? With your experience of compressors, you have done them for a week. What happens to the compressed air? Does it vanish? It doesn't vanish. It still remains on the very same bars or whatever pressure. And then as you utilize it, when it reaches its optimum, I would say reorder point. I'm using industrial terms. When it gets to its reorder point, then it will expect to trigger the motor to run and create more air. But in the event of power failure, it wouldn't be able to. But fact is, it will still retain that compressed air. So what it means is that it is possible to leave that cylinder actuated basically or in the extend position. So if you use this system, the moment you say play, it will be extended. Before you do anything, before you actuate it, so it remains on an extended position. Before you do anything, okay? Then after that, the drawing I believe should be an easy one to do. Let me see here. I have a feeling that this is the same drawing. How do I hide? Okay. Copy. I'm doing things that will complicate my life deliberately so that we can cover those aspects. So the stuff disappeared again. You see, that's why. Yeah. Then how do you bring it back? Because I know in a test this will happen. How do you bring back that? Is it a plane or drop down? It's a hierarchical view component library. So you go to, where did I go? I went to library. Oh, okay. I don't memorize anything, guys. So whatever that we do, I forget it almost immediately. I just use instinct. So you still remember the connection again? Normally we would put this here and control it directly, but they want us to do the indirect. On pneumatics, basic pneumatics, the indirect is a little bit different. On the electrical part, because of we're dealing with the electrical section, the the what you call the indirect actuation is also different because these things you actuate them using electrical circuitry, so you don't focus a lot of effort on the solenoid too much. You focus on the electrical circuitry, and the very same concept used on the electrical circuitry applies also on PLC. So now, still remember solve. So zero here, but they mentioned something critical. They said either or of the two push buttons. Yeah? So I'm going to duplicate this switch. Okay, let me take a normal push button. I need to check the normal push button to I'll use normal push button, copy paste. Ninety-nine percent of the time I can see what's wrong with your work while marking before I can. And let me not say 99, 80. I'm like, most of the time, I can see where you made a mistake and I can correct your work without testing it. But I don't like to say people must do things the way I do them. You are allowed to do a complex diagram if you want to, but you better work. So I have a PB1 and PB0. So any of the two should work. So, all right, now it's very interesting. Now it gets interesting. Yes. So why do you use it in kind of open so that, okay, let's imagine this. Yeah? Let's imagine this. I would imagine it with a flap that goes up and down. Ne? And then you want to secure those pallets. I believe the pallets are used for extrusion purposes, where they are doing bottling and stuff like that. Before you can extrude them, you store them in a tank. Then the valve of the tank must be open or it must be closed. That opening the flap, it must be open or closed. Natural on a normal state must be closed. Yes. Okay. The flap must be closed. But remember, the valve works with another type of way. Because remember, the cylinder is the flap. The valve is the tap, the one that you open and close. Yeah? And then the valve is the one that actuates the cylinder. So the valve is open so that it can allow air to make the cylinder to remain on an extended position. Otherwise, if we use the normally closed cylinder valve, it means that the valve, the flap will be retracted. And when the flap is retracted, it's more like you leaving your tap at home open. Water will come through. You understand? So there, they are actually teaching you the top part, because your solenoid is this part, is this section here. This is your solenoid, yeah? And then this is your the inside of the valve, meaning that flap that needs to open and close. But you can't leave it open because of the pellets will come out. So let's go back to the diagram and reiterate our statement. So here, if this is open, it means the product will be released. So this one needs to remain closed, but the solenoid valve must be open so that air can help the cylinder extend. Yes. So let's do this. I think this example kind of explains itself. If you can look here, these are the cylinders that are used. How can I do this? Open a new link. Let's see if I can get a bigger picture of this. This baby. See. What do I do now? Snip. And take, take this, right? Perfect. That. All right. So look at this. They are okay. On this one, they need to be retracted. So it means when they extend, this one opens as well for this type of a situation. But obviously, okay, actually, here's the cylinder here. My bad. Here's the cylinder here. On this case, yes. Yes. Okay. Of those electrons. Yeah. But it's fine. You can. Because you're gonna do electrons. Yeah. So in this case, when the cylinder is closed, the flap is also closed. So I don't know if you can, obviously you can look for other types whereby then, okay, I know what I need to look for. I need to look for GIF. If you look for GIF, it means stuff plays whenever you go next to them. Like, come on, UJ, they block everything, guys. You can, yeah, UJ blocks everything. This stuff needs to be playing whenever you go to them. But I know UJ, it's my company, but not that mouth, it's under record. But on your own PCs, you can check the different mechanisms that are used, the relationship of the valve and the cylinder on a flap valve, right? So only when we press, that's when it will open up. You understand? Only when you press, that's when it will open up. And when you release, it will extend. So what they have done here was they didn't want to invest in a cylinder that comes as normally extended. They wanted to rather invest in a valve that comes as a normally open so that the cylinder can extend, because it's difficult to amend your cylinder. And the moment you over customize a cylinder, because you have to have a spring on this side here, are you gonna have problems getting a spring this side? So basically something like that, then the spring will always extend this. You're gonna have issues. You don't want that.
So,
Yes.
what kind of a relay is the one on the far right on top of the screen? On top. That REL is.
This one.
Yeah, what's it?
Okay. It's a changeover switch. Yeah. It's the one. It actually represents a contactor. So, you wanna say something? Okay. So what happens is, you see the A1 and the A2. Yeah? Even if you could look at this one, I am positive, yeah, it does have A, see here, A2. And then this side, I'm sure it's A1. I don't know why it's not showing. Yeah, here's A1. So this is where we connect our digital signal at point A1 and point 2. Then the changeover switch, it represents a whole relay basically. So what happens is, that's where, if this needs to supply 24 volts, that's where the electrical connection is actually represented. So if it has to do, I think this one pushes up to 230 volts, 265, yeah. It can push up to 265 volts. So this is where you connect your 265 volt. But you actuate it with a signal that comes from a PLC, which is around 5 volts. So those signals, they go under the, what you call this, they go in the A and A1 and A2. If you cross paths and put a push button there, yeah, like you connect A, push button, and then B. When you connect that push button, when you press it, it will actuate. The relay will definitely connect, or the contactor will definitely connect.
So we always have to edit the change over switch.
Yes, it's very important. It's a circuitry that is representing a relay basically. Yeah. And then with this A1 and A2, they are indicating that your push buttons are actually, their signal is feeding on A1 and A2. And then the changeover is the actual big electrical circuitry that is happening. On this case of the whole system being 24 volt, it doesn't really, make sense. But you must know that this is a major voltage for your 500 volts and stuff like that, that needs to control your motor.
And where do you find it here?
Under general switches, we have what they call a changeover switch. Yes. Let's see if I can get a what do you call that? Contactor, contact. What do you got? Wireless diagram. Let's see if I can read the wireless diagram. So, the wiring diagrams are way too. Oh yeah. I found them. This. Why every time when I move this, it changes altogether? So here's your wiring diagram for a what you call a contactor. So you have A1 and A2. Those are from your digital signal, and then you have These are live. You see, live one. So this one is a three-phase contactor. So whenever there is actuation coming on A1, this connect, and then they release that high voltage that you require to run your motor. So normally the circuitry will be like something like this or like this. Why is Google no longer doing a proper image? It's boring this thing. So your push buttons are connected directly to the what you call to to the contactor. Then through A1 and A2. Then the contactor is connected directly to. So we are already using a normal switch, like a normal circuit breaker, basically. And the reason why they use a contactor instead of a normal circuit breaker, you have to check it with your electro or electrical guys. They will explain exactly why should we use contactors. But all I know is the conductors, they play a vital role in the era of automation, because you would want to send a signal to the motor, but you can't send it on a normal circuit breaker. You'll just, ruin stuff, basically. They serve the purpose of a circuit breaker, basically. Because they when they connected, electrical connection flows or current flows to the motor, and then the motor starts to run. Right. But I still need to confirm this on its memo so that, because I don't claim, I just applied my understanding. Let me check the memo. Is that memo? Yeah. Yep. Exercise number 4. Ah, that's correct. All right. Yeah. So my point exactly. The software doesn't allow us to customize. So they use the 5-2-way valve. And I always said it is best to use a 5-2-way valve. So on a normal instant, a 5-2-way valve, when you actuate it, it will change from 2 to 4. But now they've blocked 4. Then they've let 2 to function. Remember, 2, it is designed to keep a double active cylinder on its retracted end position. So they use it to push, they use 2 to push the cylinder forward. Okay. But you can still use a 3-2-way valve. But financially speaking, it's not smart. Exercise number 5. Page 5. Why are they coming so many things? No? Hey guys, if you wanna read those things, read them. Not told you I'm teaching you designing of circuits. Right? Okay. Diverting packages. Right? As you can see here, we've done something similar to this on Factory O. I hope if I could get a chance, we would do such an example when you do PLC. Okay, they want you to understand the function of a double acting cylinder, and then a double solenoid valve. Okay, and the graphite. This one you don't need to go with. I will teach you more advanced stuff, which is PLC. If you don't need to understand graphite, you can teach yourself. Once you understand what goes into a PLC, you will definitely be able to use graphite. I can teach myself within 24 hours and be competent enough to teach other people. So yeah, that's how simple I take it. Packages will be diverted from one conveyor to another by means of a diverter. So they call this cylinder a diverter. Then, so we still not, according to what we're expected to understand, we understand that it is a double acting cylinder, right? The diverter gate is advanced when one of the push buttons is activated. One of the push buttons, okay? The package is transferred and transported further. The diverting gate is returned to its initial position when the second push button is activated. So, what does it mean with the first push button? You press it and you let go. And then the system will carry over. So it has a mechanism called retaining. It can retain itself, it can latch. So it advanced when the first push button, they were not, when I say one of the push buttons, they didn't make a statement that says either. It's just one of the push buttons. So I don't like posing questions like that. I per se say the first push button on my case. This how I will test you. I cannot design the test, so I'll tell you how I do it. So diverting gate is returned to its position when you press the second push button. They should have just said the first push button. It's unnecessary. So double acting cylinder will be used, okay? That it's given. Remember I said we don't negotiate that one. And then now they want to say the cylinder will be controlled indirectly by means of push button. In the event of electrical power failure, the cylinder's piston rod should remain in the current end position. So this is about 5-2-way valve. We know that 5-2-way valve naturally has power leading to retraction of a cylinder. So it will remain in its initial position. These, remember, guys, like I don't know mechanical lecturers how they set their test, but in industrial, they'll give you a storyline that means nothing to the test. They only ask you the question at a later stage, or just put fragments of the question in different locations and flood you with a lot of information that you don't need to answer the question. I hate that, but it's fine. Me, I'm straightforward. I will tell you what I want. Why? Because industry will never complicate stuff. They deal with money. Unless your job is to, maybe as a consultant, you are required to break through complicated stuff. Maybe the guys in the plant, they messed up the system, the go-slow system, when they strike, they appear as if they're working, but there's no output. So yeah, you must be careful of such. It will happen. So maybe in that case, you might find, unnecessary information in whatever that you are busy trying to solve. But otherwise, reality works straightforward. We will be told that we want 5 cylinders, 5 solenoid valves, 10 of that, 10 of that, and they need to apply. And we're charging 1 million rands. So if you make a mistake, somebody must pay. Okay. Solenoid valve application, describe function of the solenoid valve, calculate the current consumption of the solenoid valve. Come on, it's unnecessary. Yeah, but yeah, if you want to do all those stuff, equipment here, you are free to come anytime to build. The wiring tends to be complicated for visually. Normally, I record and I show them, they just, no, just too much. They look like spaghetti, and you need to be able to read all of them. No, you won't read. Okay, so let me draw. Where do I draw? I can leave this one for next week. Create another one here. Okay. Maybe I must ask people. What do I put first? Compress. Okay. Secondly, right, and then thirdly, cylinder, double acting cylinder, call it by its name, guys. Then on the center, kind of a valve. Okay, I'm going to put two types of them. I know you don't understand their functions yet, but you will just now. And then the other one is this one. I've never taken you through the actuation points, the pilots. They call them pilots. So on this one, you still remember how it functions. When you actuate this side, something happens. When you let go, something happens as well. But this one is a different animal altogether. On this one, when you press this side, it remains extended. There is a latch mechanism inside. And there's a latch mechanism inside. Or there's the ability to memorize its first signal. Then when you press on the other end, it goes back. You see that? Okay? So that's what we're going to be actuating. We get it? So now let's draw the second. 24 volts there and there. Good work. Right. It's been a long time since I've done these videos. Last year. Right. So now I'm able to connect like this. Right. Make a nice straight line. The borderline, guys. The borderline. Hey, the borderline is a problem. Trust me. The borderline is a problem. And I strongly recommend that you try to work towards the beginning of your page, unlike towards the borderline. Everything that crosses the borderline creates an error. Let me try. You see? And it will take you forever to resolve it. And if it happens that you feel like you didn't have any choice, just continue with your work. I'll just penalize you 2%, 5%, and I'll mark you as if everything is correct. But I don't encourage it. If you can avoid the borderline, avoid it. I'm sure you've never been taught and somebody explains the possible challenges you might come across. So me, I've been doing this forever. So every year, students come up with different problems. Over time, I got to know almost all of them. I didn't cram them, I know all of them. Right? Let me try to be fast. I don't know when this class is ending. When is it ending? At half past? 25 past? Oh, I know. Okay, push. All right. So we have two push buttons, right? One and two. Okay. This one you can put it far off. So the one that helps with extending, that's connected. Remember indirect actuation. That part is non-negotiable. Indirect actuation. You can come closer to your, if you want, because the diagrams tend to be complex as time goes on. Okay? And then obviously we're gonna have this chip over here, the change over switch. The actually there was no point of making this. Guys, in other instances, companies might require you to connect your changeover switch as a normally closed. Get me? So, from the point of the electrical circuitry, you might be required to connect it as a normally closed. So that by its nature, the system is running. Then when you press the buttons, then that's when you get it to stop. You might be required, especially for safety systems. They might come as the normal close, just like your emergency stop button. It tends to come as normal closed. You will see when we do the stop buttons very soon. So, so this circuit, it's PB1. I love the underscore instead of space. Ne? And it goes very far. Zero short. We start at zero. In PLCs, we start at zero. Zero is a very important variable, and occasionally stands for off. Then we have relay underscore zero, not dash underscore, not this underscore. Okay, and then we have solve and Ruga here. And you behave that guy for us representing him in the lab. But I like him, he's from my hood. I'm from Phosphorus, guys, by the way, if you're wondering. And then here, our relay is to connect to the changeover. We have seen the circuit, and I did try to explain it to my best ability. Guys, something that I never do on a normal basis, copying and pasting. I never do that, but let's do it. Because you'll be dealing with more complicated circuitries, so you need to know how to do it. But if you don't change the labeling represents the cabling. Yeah, I think that's the best explanation. The labeling represents the cabling. So for the fact that we're writing out 0 and 1, it becomes much easier to make amendments on your circuitries. So the solenoid valve is connected here on sol underscore 0. That's not underscore. Why do I miss underscore? It must create another underscore. This underscore is not working. Sol underscore 1. Right. So now start. If I press this, you go forward. Connect once on the system and it goes forward. Then when I press this one, connect once on the system and it goes backwards. Do you see that? Guys, remember this. This is still going to get complicated. In a test, I might say the circuit itself must have the ability to retain the circuit itself. Yeah? So keep that in mind. Keep that in mind. I always confirm with the answers so that I don't lie to you guys. So it's correct. Another question. Hypo. What's wrong? Sorry guys. Alright, here's it. So the circuit hasn't changed much from exercise 1 to 4. We're still using almost the same circuitry basically. Now we have two push buttons. Because on the previous book, by this time, you'll be doing like way too complicated stuff. These ones, they're not even test standard, these ones. Okay, can I move now? Because I wanna finish early, at least by quarter past. I should be done. So the last exercise for the day is exercise number 6. So, what do they want from us, these guys? You will be able to allocate components of electro-pneumatic control systems to pneumatic and electrical circuit diagram. You will be familiar with the setup function of a limit switch. Limit switch, okay? I wonder what this means. And then you will be familiar with one of the options for end position. You see that end position sensing in cylinders. We've covered this already. So you need to be able to tell whether the cylinder is fully extended or fully retracted. This is the section. Now engaging in testable exercises. This one qualifies to be a test. I'm not saying it's a test, it qualifies. Did you know that for us to it is possible for us to control these solenoids using you don't know the software. Using the software called Codices. At the setup right now, you can leave the secretary here and go to Codices, create the communication using a software called OPC and control this. It is possible. But this one is still enough. You don't need to complicate your lives. I'm gonna catch you on Codices either way. It's coming. You know your favorite series, The Winter is Coming. It's coming. So the end positioning sensing mechanism. And then do they want element tables for relays? Switching element tables. Hey, these guys. I can't wonder they are training people, so they cover everything that they see is necessary. To me, whatever that I teach is whatever that I'm going to test you on. And only thing I expect from you guys is just simple practice. Don't cram, just practice. Apply your mind. Have an open-minded approach to this. Don't aim to kill students. I'm not like a typical lecturer. I'm a lab technician, and I value that. My aim is not to fail anyone. But if you come here, want to practice a day before, trust me. The test natural, on its natural state, will filter people who didn't practice. On its natural state, before it gives you the challenge. So it will be a 0 on you. Wooden boards need to be pushed out of a stacking magazine and into a mounting device. Right? Over here, hey, this drawing, I like it. Although, it only makes sense if you can reproduce it on a 3D machine. So, this is a sensor here. It senses whether the woods are on motion. Yeah? So basically, if it happens that again it pushes out these planks, yeah? The boards, let's say wooden boards, yeah? Push them out. But if it happens that how can I put it? If it happens that the wood has not left this area, the cylinder shouldn't push again, basically. So what it means is, dude, there's still a product on there, so you don't need to push. Because if you keep on pushing, you create a situation whereby the system uh, jams in a way. Yeah, so it will clog in a way. So the sensors are avoiding that. You push out one product, then you retract. Push out one product, then you retract. Simple as that. But let's read the question what they trying to say here. All right. A wooden board is pushed out of a stacking mechanism with a slide after pressing a push button. Okay? After reaching the front end position, the slide is returned its initial position after it has reached its extended position. But if it hasn't reached that extended position, it must not return back. So you need to confirm that, basically. So the cylinder's end position must be sensed. You get it? So then they want, oh, then that function actually is a function of a limit switch. That function is a function of a limit switch. Right. Then let's do it. This one, I'm going to take it from this one. It's the same thing. And this one. Yeah. So now you actuate going forward, and then you are expected to sense, ne? So that you can go backward. So you need to sense. So what do I put here? Sensor. Okay. This can represent the sensor because it's got the normal push button. Okay. Ah, now I remember now. I had forgotten how to do this, but now I remember. So now the sensor must correspond with the extension of the cylinder. We talked about this last week, that at times you are required to sense the position of, okay, when the cylinder is extended, then the sensor would be maybe somewhere here. So it will sense that this thing is extended, then it goes back. And I made also an example whereby we have that sensing mechanism whereby it's wrapped around the cylinder body. Still remember? So we are now doing that example actually. So now, when the cylinder closes, in simple terms, what it means is we extend, and this will give us a signal, and then we come this side and press off. Why you press off? Because I didn't label you, don't want to wear. You sensor Z S underscore extend. I don't have a proper name, but yeah. Surprising. Then, oh, these ones are not actuated easily. Yeah, they only actuate because of you should finish the entire circuit. They're not like push buttons. Push buttons, the software remembers that the push button it needs to work in a certain way. So which is not a problem. Now we're gonna go to the ruler. Let's introduce a ruler. On the software, on real life, I'm gonna go to my table and extend and position a sensor there, and the sensor will do the work. But on the software, we use a ruler. And I did mention that measuring tape that you need to use it in the industry. I did mention it last week. Yeah. So here we use a ruler. Here's your distance rule. Then you open it. Then the S extend comes here on the label. S underscore extend. Then the software corresponds very well with the cylinder. I believe when the cylinder is fully extended, is it 100 millimeters, this one? Engineers. Is it? And it? Hey. And, okay. One of you must measure it when you get a chance. I won't be like it. Looks like 150 to me. So, we're going to say 100, 100. Even on my national diploma days, which was in 2012, we didn't mix anything here. So when something you wanted to measure is fully extended, you say 100, 100. The late doctor, because he's gone now, he didn't give us any other possible ways of doing it. And I've been doing like that as well. I can't mix up these numbers. If I want to sense the beginning, I do 0, 0, and that's it. I haven't been able to mix them, and I don't have any reason. And unfortunately, on my training, because I got trained, I think 3, 4 years ago, they didn't cover this because we didn't do the software part. So I'm going with the inspiration of my master. So don't ask me why are we not mixing. 100, 100, simple. So now, I want to put the ruler somewhere. The only wants to sit here. I want to zoom the ruler. Look at the ruler. It has a line now. You see here. It shows you this only works when it's at 100. Let's put it on 0 and demonstrate and see what will happen. 0, 0. You see the line goes to the 0, 0 at the ruler. So it indicates the position of the cylinder when it's retracted. And then when you put on 100, it will only measure when the cylinder is retracted. The 100 comes from this 100 here that they are talking about here. And then they do the 100 through the meters, the centimeters, the inches, and the feet. Right. So now the sensor, see, they share the same name. So once this is extended, the sensor will tell us and retract. So, but it's happening very fast. It's coming back very fast. So to slow up the process, we're going to put what? One-way control valve. Let's put it there. So in order to put it nicely, break down your compressor and so that you can have enough space. Okay? So now I want to put only one. Remember, this qualifies to be a tested one. Using 2 makes you guys to just leave it there as a normal. I want to slow down the retraction force. How do I do it? Which one must remember that the 270 is given. Now, where do I position it for retraction purposes? Let's zoom. Left side. My left.
Your left.
Okay, left. So the air will blow like, and then it won't be suppressed here, it will only be suppressed here. So then as it goes back, okay, I believe you. Let's do it. All right, let's reduce now the force. Put that on 5. Okay, then we tap, then it comes back slowly. Yes, that's correct. So you press, comes back slowly. But now you can't really demonstrate the whole thing, unfortunately. Uh, but what it means is if this, remember, no, what are they saying? No, no. What are the implications here? Only one is okay. Maybe I don't answer this question properly. I rushed through it. What are they saying? We are just sensing the end position. What are the other requirements? Maybe I'm rushing. The cylinder front end position. Okay, only this. Okay, so a wooden board is pushed out of the staking mechanism with a slide mechanism pressing the push button. Okay, after reaching the front end position, the slide is returned to its initial position. It means it's not the question that I was trying to address, because I remember that it worked a little bit different, but it's fine. Nevertheless, I believe this is correct. Let's see. Which size is this now? This is 5. This is, okay, where's the sensor? There is a sensor. Okay, they usually sensor in the form of a change over. So this is yeah. Okay. And reach here. Okay, alright. No, it's fine. This is fine. There will be a situation whereby, so, but one fact is it will never return without fully extending. Yeah? Only after fully extending it guarantees you that the part has been removed properly. Then after that it retracts. Are we clear? Yeah, so I think my explanation earlier on, I rushed to explain a certain concept, but there was no need. It was too early, prematurely. So guys, this is our second. And is the last one of the day. Start practicing as soon as possible. Whenever you have issues with your laptop, not wanting to install, let me know. I will help you. Uh, guys, I don't know. In the whole department, only person whom I can say is better in computers is Prof. Yeah, he tends to know a lot. Although I trust myself in computers, I can help you even when you're home. I can remotely control your PC even when you're home. If you're struggling to either install the software, I can take you through via Zoom, like remote control is there, or any desk. I can do that with you. Even when you want to consult, you are stuck. I'm an open book. I'm Branik. I'm the simplest guy in the whole department. So if you're stuck anytime, holler at me. So thank you so much once again. I will see you on Friday, and we change more gears on Friday. I hope the sun was going through.
So, sir,
Yes.
is it fine if you use the changeover as the center as they did on the movie?
Yes.
Long as the circuit breaks is already supposed to
Yes.
it's not like